Okay, so we will see about matrices. And what is a matrix? So matrix is a technique. Okay, matrix is a mathematical technique in which you can actually deal, you can do operations on a group of numbers, a group of quantities. Okay. So if you see in the earlier class and all, what you have done, you have done with a single numbers, right? So 1 plus 1, 2 plus 3, or 1 into 2, or 2 into 3. So all those things you have done, this is all happening with the individual numbers. If I want to perform operation on a group of numbers, okay, you have done it, okay, so but you didn't realize that you have done it, you will see it later on. Okay, and when you have to perform operation group of numbers, then matrix is a one method which makes it very easy and very convenient. Okay, so and so that's what the so matrix is a mathematical method where you can perform operation on group of numbers. In a simple way I am putting. Now we can, if you want to see when a group of numbers will come. So your question is, normally we deal with the one number or one number, 2 plus 2 or 2 plus 3. When in a situation you are going to get a group of numbers. A simple example is a coordinate system. This is x and this is y, and I am going to define a point here. So any point in the coordinate system is not going to have a single number. It will have two numbers, am I right? x1 comma y1. So now I am going to do an operation on this point. That means I am going to move this point from this position to some new position. Okay, so then the new position may be something here, that will be x2 comma y2. Now I have to deal this whole process of moving this point x1 y1 to x2 y2 mathematically. So when you want to put up such a question and when you want to deal such a problem, this matrix method will come into picture, and that will be see, this you don't need to really should have a matrix method. You can do many methods or you can deal it. But matrix, by using matrix, this type of problems can be handled very easily, and you can get a solutions also very effectively. Okay, that's what the matrix method comes into picture. So then basically, I have to define, I have to group up these numbers. So the matrix representation of, let me call this point as, so let us have a name for these points. What's the name I can use it? Tell me. You want to use it A and B? No, A and B I may use it for some error. So let us call P and Q. Okay. So then what am I going to call? So I will represent P as a matrix form. So this is a matrix form, x1, y1, and Q as x2, y2. So this way I am going to group the numbers. Suppose I am not having only two numbers, I am having another one number also. Say something like this. So initially there was another one point also. Say something here. So this is your, let us say x3, y3, and which is being moved to when this moves to x, when this, okay, I'll call this as PQR. Okay. So when P is being moved to x2, y2, the point x3, y3 moves to different place. Understand the point? So now this is going to move when the P3, when P is moving to Q, R moves to some PQR S. So R will move to some S, and which is x4 comma y4. Sorry. Okay. So this is S. Now this is not arbitrary. My point is there's a systematic way. When the P moves to Q, R moves to S. That means this operation I am going to have, it is not going to have only on this only 1 point, 2 points. Then again I have to combine these two numbers which has evolved to these two numbers. Okay, so in that case what will I do? I will write my initial matrix is x1, y1, x3, y3, correct? Which moves to x1, y1 moves to x2, y2 and x3, y3 moves to x4, y4. So this way of representing the group of numbers is called as your matrix. Okay, and then we have to see now what happens. So if you wanted to if I want to go further, which will be slightly complicated for you. So, but anyway, you will eventually understand what I mean. Suppose, for example, this point. Let us take this point value. So this one, which is being x1, y1 is being moved to x2, y2. So let me call the operation of moving this x1, y1 to x2, y2 as, say, something like your x, operation x. Okay. So then that x is your, what typically the language in a higher class you will see, the operation which moves this type of point number group of numbers you call as an operator. Okay. So, and the, okay, here you don't have to remember about operator and all. You will see this x also will come as a matrix. This is a matrix which actually moves from point x1 to y1. Okay, so then I will have a matrix x. Okay, so which I will call as A, B, C, D. Such that if I multiply A, B, C, D with this matrix x1, y1, this should give me x2, y2. Am I making it clear? So we don't know what A, B, C, D and all. Okay, we don't know. What I'm saying is something, some notation I'm developing. I'm developing a terminology, developing a technique by which I have to move this point x1, y1 to x2. So what I will do, if I multiply with some matrix of this form, and then this will go to. I don't know what are the operations I have to do it. We will define that. Okay, so how do I multiply these two? We don't know. Often it is not that you just A, B, C. I have to define. I have to develop a technique to find out this A, B, C, D, such that if I use that technique to use this x1, y1, it should become x2, y2. Okay, so that we will see how to get the technique. So that's what we call as your. So when you do this type of thing, you call that as a matrix multiplication. Correct? Is it a multiplication? Because you are multiplying these two quantities. And that multiplying quantities will give you, right? It's something like your 2 into 3 equal to 6. So this is a matrix multiplication. So this is what, in short, how we, what do you mean by matrix? And how this matrix algebra has to be defined. So this is a multiplication. Similarly, there are cases you have addition also. Matrix addition. Okay. So matrix subtraction, multiplication of a number with a matrix. All those things will come up. Okay. And only thing is matrix doesn't have a division. So all the division we have to do it as a, take it as an inverse and then you multiply. That we will see it later on. Okay. So and okay, fine. So this is what we will do and fine. So the first, okay, let us go with this one only. Okay. So let me, for example, let us take a simpler case. Let us not take this one, complicated to the second point. Let us handle with only 2 points. Okay, am I right? Let us handle with only 2 points. Let us call this point, let us put the values, number values. So let this point be 1, comma 1. So let this be 1, comma 1 and we are moving to a new point. Let us call, okay, I am not going to draw it like this. So let me move to a new point. So let us take a move point that will be 4, comma 3. Okay. So this one, so don't go by scale and all, I am just giving a rough answer, rough way. Okay. So this is P and this is Q. So let us take an example of this problem. So now the whole thing what I am saying, so this becomes 1, 1 and this becomes 4, 3, correct? So then our matrix problem will become like A, B, C, D into 1, 1 should give you 4 and 3. Am I making it clear? So now what should be ABCD? Okay, that's the question. What should be ABCD? So, and that is not, I can't simply say ABCD as any value put up. Okay, so something, it is not just even giving a number. I have to see how am I going to operate this ABCD with this one. That should give me 4 by 3. Okay, and that is, as I told, that comes as a matrix multiplication. Okay, and then you have to define a rule. How am I going to multiply this matrix rule, multiplying these two matrices? And then when you define a rule, then you can find out based on that rule what should be your A, B, C, D, which should give me 4 and 3. Am I making it clear now? Any doubt you have? So this one. So before identifying what A, B, C, D, I have to define a rule because this is a completely new notation. You got it? So what is the commonly adapted rule for a matrix multiplication? Okay, so that is a very nice way of writing the rule, and it is very easy to remember also. The point is, suppose if I have, let us take a simple matrix, two matrices, A, B, C, D, and I am going to multiply with another matrix. I will take same type of matrix, E, F, G, H. How do they find it is first row, first column. This is okay. This is what you call as an element of matrix. Each quantity is called as an element of the matrix. What happens? You multiply the elements of first row with the first column and take a summation of all. So that comes to first row, first column becomes first row, first column value. Okay, elements. That means what? A into E. So this is what I am going to, let me put another color so it will be easier for you to remember. Okay, so what am I going to do? I will make it A, this one and this one. So this is first row, correct? Yeah, I didn't define your row. You understand what I mean of row? In a matrix, this is a row and this is a column. Okay, the first row and first column will make it as a first element. First row and second column will make the second element. Second row, first column make it first. Second row and second column makes it this corner one. Okay, so you can just make simple pattern. This is the rule I am defining. Remember that. Okay, this is the rule, and based on that rule, I have to find out what my ABCD. Let's say. So then what happens? So this will be first row and first column. How am I going to do? A into E, B into G. I add them both. So this will become so what will be? Tell me. This is A into E plus B into G. So this will make my first element. Second thing is first row, second column. Correct? So that will come here. What it will be? A into F plus B into H. Okay, and this is a rule. Remember that we have to follow. Once we have to follow. Why we have. This is not a method. You can. Why you have to prove or something. This is the rule we are defining how two matrices should be multiplied, and this rule has to be adopted universally. Okay. Otherwise, if you define your own rule, then the whole problem is going to be you can't communicate with the different people. Right. So that's what I'm saying. If I call no, I will not call 1 plus 1 equal to 2. I will call 1 plus 1 equal to 4. Then if you can't define the whole thing, then you can't communicate with everyone. Am I right? So the same way. So here, so therefore this one will be what? C, the second row multiplies with the first column and makes it second row, first column. The element, right? So this will be C into E. Correct? C into E plus D into G. You understood the way? How am I writing? You got it? So first element, second element, you have to go like this. And then Next one is this one, last one, right? This and this, correct? What it will be? C into F plus D into H. Am I right? So this is the way I am going to define our matrix multiplication. I have defined a rule for matrix multiplication. Now I have defined a rule for multiplication. Then you can find out where A, B, C, D is. How will you find out? Tell me. I'll just put down the number. Okay, let us see how we will get later on, and let us see whether the number satisfies or not. Okay, so I am going to write this as 1, 1, 1, 3, and 2 and 1. Now you try to use this rule. Is it correct? Now the point is, there you are not having 2 columns. So only 1 column. Okay. So what will happen? 1 into 1 plus 3 into 1. How much? Correct. So what it will become? So the first element will be, so where will I write? Yeah, fine. So let me write it down here. So first element will be 1 into 1 plus 3 into 1. Correct? And now there is no second column at all. I can't move any head. Correct? So I have to stop it. So then that's it. Now then I'll go for the second row, because second row and first column can work, right? So this will be 2 into 1 plus 1 into 1. So what this will be? Tell me. 1 into 1? 1 plus 3? 4 and
2 plus 1, 3.
Are we getting? Okay. So this gives me a clear idea. So if I can, so now since you are able to construct an rule, okay, and you are able to construct a matrix also, so then this gives you a very tremendous power. What is the power? Instead of dealing with a single number, you can handle with a group of numbers very effectively. How do we find this matrix? That we will see later on. It's a very easy way to find out this matrix and all. So that's what this whole technique of matrices is. So the matrices give you ability to handle a group of numbers, and many complex problems become very simple and very easy when you handle with the matrix algebra. Okay, the whole matrix algebra, the important part of the matrix algebra is a matrix multiplication. How do you define the matrix multiplications? Once you define the rule for the multiplication of a matrices, then the many problems can be solved very easily in a very effective way. Okay, compared to a normal algebra what you are doing. Okay, so this is what happens. So remember, we have just defined matrix multiplication. So then we have to define other properties also. Matrix addition. Okay, matrix division won't be there. The matrix division is also dealt as a multiplication. That you will see the later on classes, probably next year classes. Okay, what happens? I can give you how this division comes in a simple way. Okay, so for example, this is what you have done is, so our point is, this is a point P and this is a point Q. I mean, when the division will come, I'm explaining you. So this is we call as let us call this matrix as X. Okay. So the X acting on this point will make you to this point. Now I invert the problem. I'm asking, I am starting from this point. Take me back to this point. So you know this into this goes this one. So in that case, what happened? So, yeah, exactly. So what happened? So then you are having actually X acting on P will be equal to Q. Correct? So now I am asking, what I invert it. I am having Q. What should act on Q, which should give me P. Okay. So that will be typically upon X. Am I right? Correct? Because if I write P equal to Q by X. So this they write it as X inverse of Q and P. Okay. This is X inverse is not just 1 by 2 or 1 by 3. is the inverse of a matrix of this form. You got it? So this is not very simple and straightforward. What do you mean by the inverting this matrix? 1 upon this matrix. So these are all the techniques. Okay, how to invert a matrix? I think probably you will not have in this 11th standard. You will have it in 12th standard probably. That time you will see that. Okay, so this is the exam line. So once you define all those things, if I know how to invert a matrix, then you will see I can always move from point P to Q or Q to P also. Not just for 2 points. If I have how many number of points or how many number of number group, it is I just guess a point. But if you have a group of numbers, I can always move one group of number to another group of number by using a matrix. And similarly from there to back I can move. Okay, so this is a powerful technique to handle such situations. Okay, and okay, I'll give you something very, let us go into the matrix, detail of the matrix later on. I'll give, you understood the concept of matrix, right? Why we are introducing the matrices. And that's an interesting way, this is not in your book, I can explain you. So what it is, see something, so if I have point 1 comma 1, so this, and this is my origin, right? So if I join 1, I can always, I see this as a vector which is going from 0 to point 1. So when I'm moving this point 1, 1 to another one, that means I have moved the vector from one vector into another vector. Correct? So that means this point 1, 1 can be seen as a vector also. Correct? So that means what happens? So we can see this point x1, y1 as a vector. You have studied vector? Okay, you will see. So when we say a vector, so normally what this is, the simple is you write P, you have an arrow over it. That means having a direction. So, and Q is also a vector. And that if you remember, I was writing for all these points small p and small q, whereas this I am making as capital. That's the definition, that's why I'm using it. That's the way people use it. Okay. So this is a vector. In fact, what happens, so this whole problem can be seen as a vector algebra also. You will see in your physics next chapter, second chapter in physics, you will deal about this vector algebra. That time you will see, that time I will introduce this also. I'll bring you this, how this can be done. It will be interesting. Okay, so this, the first thing that when you have a vector algebra, there you will see a different type of vector algebra. That also can be handled in a matrix problem, as a matrix way. Okay. And in that case, what happened? So, what you will call this is a vector, okay? And the one which the operation which is going to move one vector to another vector, whatever you're going to do, that you call as your operator, and the symbol is this. So this should be, this is the way it's being done, and this is a dot product. Okay, it's a product. You will see those things and all much later on. What do you mean by dot product and all those advanced classes? Okay, and the only one interesting thing I can, I guess that I will do it when I come to determinant. Just remember it. Okay, so you should always remember whenever the mathematical technique we are dealing, these are not just a blind technique being done. It has been used for some purpose. Okay, so you will see when we go to next part, that is determinant. What do we mean by a determinant? After defining a matrix, next time we will go with a determinant of a matrix. That I will, when we come to determinant, I will show you that. Okay. So for time being, what's the important is, we are going to define a matrix. Matrix is what? It is a group of numbers, and which is combinedly they are going to change. So how to deal with such a problem? I am introducing a matrix method, and then I club up those group of numbers, and any more change in those numbers, I act as with the form of another matrix. Okay, and since I have written this form like that, so now I have to define a rule of how this operation has to be done. I have defined a rule for the matrix multiplication. Once I define a matrix multiplication rule, I can actually easily handle all the numbers together. Okay, so this is what, in short, what do we mean by matrix, matrices, and the matrix algebra. These are all algebra, right? You're multiplying a matrices you will have. So And in the next class, we will see more detail about matrix algebra. Okay. No, more than that, I will say we have to define some of the definitions of the matrix. We will look the definition of the matrix clearly. Some definition which will be used when you are solving many problems. You have to define what do you mean, what are the types of matrix, all those things, and then we go into the matrix algebra. Okay. Then finally, I will go into determinant. So then I will say how determinant will be useful for all. When we learn determinant, then I will take you to some of the problems which you actually solved in your 10th standard. Okay, and I will see where you, if you remember a linear equation in two variable, right? You have two equations and then use what are the methods you use? Substitution method, all those methods you use to solve it, right? Suppose that is the only thing what happened, you had only two variable, correct? X and Y. You substituted and you did. I'm giving you, okay, can you solve a linear system of, you need two variables, you need two equations. Now I'm asking, can you solve it for 10 variables? And I give you 10 equations. You got it? So when you use that method, you will see it become, it's almost impossible for it to solve. And when you introduce matrix, you can see that can be solved very easily. Okay? And that we will see it in the next class.